You touch something too hot, and before you even think about it, your hand is already pulling away. No decision, no hesitation, just instant, sharp, unmistakable pain. It feels like an enemy, something your body does to you rather than for you. But why does pain exist at all? Why does the body choose to hurt you? The answer starts with a much stranger question. What would happen if you couldn't feel pain at all? There are people who actually live with this condition, a rare genetic disorder called congenital insensitivity to pain prevents some individuals from ever feeling physical pain from birth. It sounds almost like a superpower. In reality, it's incredibly dangerous. People with this condition often suffer severe injuries without realizing it, burns, fractures, even bite wounds, because nothing warns them that something is wrong. Many don't survive childhood without extremely careful supervision. This single fact reveals something important. Pain isn't a flaw in the system. Pain is one of the most important survival tools the human body has ever developed. To understand why, we have to look at what pain actually is at a biological level. Scattered throughout your skin, muscles, and organs are specialized nerve endings called nociceptors. Their entire job is to detect potentially damaging stimuli, extreme heat, extreme pressure, tissue damage, harmful chemicals. When a nociceptor detects danger, it fires an electrical signal. That signal races along nerve fibers toward the spinal cord at incredible speed. In many cases, the spinal cord itself triggers an immediate reflex, pulling your hand away before the signal even finishes traveling all the way to your brain. This is why you often move away from something painful before you consciously register what happened. Speed matters enormously here, because damage can occur in a fraction of a second. Once the signal reaches the brain, several regions light up almost simultaneously. One area processes the physical location and intensity of the pain. Another area processes the emotional response, why pain feels genuinely unpleasant, not just informative. This emotional component is crucial. If pain felt neutral, like a simple notification, you might easily ignore it. Instead, evolution made pain feel urgent, distressing, and impossible to overlook. This ensures you actually respond to it rather than continuing to cause damage to your own body. Pain, in this sense, isn't punishment. It's an alarm system finely tuned over millions of evolution. Different types of pain exist for very different reasons. Sharp, immediate pain, like touching a flame, teaches rapid avoidance. Throbbing, lingering pain, like a sprained ankle, forces you to rest and protect an injury while it heals. Deep internal pain, like stomach pain, often signals problems you can't see or touch directly, forcing attention towards something otherwise hidden. Each type of pain evolved to solve a slightly different survival problem. Animals experience pain in similar ways for the same underlying reason. A fish that feels no pain when injured might continue swimming directly into danger. A mammal that feels no pain from a wound might keep using an injured limb, worsening the damage. Pain across species exists to protect the body from making the same mistake twice. But pain isn't only physical. Humans also experience emotional pain, grief, heartbreak, social rejection. Interestingly, brain imaging studies show that social pain activates some of the very same brain regions as physical pain. This overlap isn't a coincidence. For early humans, social connection was directly tied to survival. Being excluded from a group could mean losing protection, resources, and support. The brain may have repurposed physical pain circuits to also flag social threats as urgent and distressing. In this light, a broken heart and a broken bone aren't as different as they might first appear, at least not to the brain. Pain also has a fascinating relationship with context and attention. Soldiers injured during intense battle have sometimes reported feeling little to no pain until much later, once the immediate danger had passed. Athletes competing in high-stakes moments sometimes finish a game on a significant injury, unaware of its severity until afterwards. This happens because the brain can temporarily suppress pain signals when survival or immediate performance takes priority. This natural pain-suppressing system involves chemicals called endorphins, which are released during extreme stress or exertion. Endorphins act somewhat like the body's own natural painkillers, dulling pain signals temporarily when focus is needed elsewhere. This explains why pain sometimes feels delayed, arriving only once danger has passed and the body can safely process it. But if pain is so useful, why does chronic pain exist? Why do some people experience pain long after an injury has fully healed? In some cases, the nervous system itself becomes overly sensitive, continuing to send pain signals even without ongoing tissue damage. This is sometimes described as the alarm system getting stuck in the on position. Chronic pain remains one of the most complex and actively researched areas in modern medicine. Unlike short-term pain, it often stops serving any clear protective purpose, becoming a medical condition in its own right rather than a useful warning signal. Understanding this distinction has changed how doctors think about treating long-term pain today. Pain tolerance also varies enormously between individuals. Genetics, past experiences, culture, and even expectations can all influence how intensely a person perceives the very same painful stimulus. Some researchers believe this variation itself may have evolutionary roots. Different tolerance levels may have been useful in different environments and lifestyles throughout human history. Despite all of this complexity, pain's core purpose has remained remarkably consistent. It exists to protect you, to teach you, and to prioritize your survival above your momentary comfort. Every wince, every flinch, every sharp intake of breath is a signal shaped by millions of years of trial and error. Bodies without effective pain evolved poorly, if they survived at all. Bodies with well-tuned pain systems avoided danger, healed properly, and passed those same protective traits on to the next generation. So, the next time you feel pain, remember, it isn't your body failing you. It's your body doing exactly what it evolved to do, protecting you in the only language it has ever truly known how to speak clearly.